Hey everyone, welcome back to the sorting algorithm playlist. In today's video, we are diving into our very first algorithm, that is bubble sort. Bubble sort is one of the simplest sorting algorithms, great for building a strong foundation, and in this video, we'll be learning it in the most intuitive way possible. First, we'll go through a step-by-step visualization and dry run so you can see exactly how the elements are compared and swapped. This will help you build a strong mental model of how the algorithms work internally. Now, in this whole video, we'll walk through how bubble sort compares adjacent elements. Second, how larger values bubble up to the end with each pass. When the array becomes sorted and how many passes are needed. Once we understand the working, we'll move on to the implementation part in C++, where I'll explain the code line by line. By end of this video, we will have a solid understanding of how bubble sort works, a complete code implementation, and the ability to analyze its time and space complexity. So let's just jump right in the visualization explanation of bubble sort. Now, as you can see here, we are taking an input. Okay, there are five elements. Suppose consider this as a list or an array. Okay, so there are total five elements. Now I'll explain you in brief what is happening here. Okay, what happens in bubble sort. So adjacent elements, suppose for example this 8 and 5, between this 8 and 5 comparison will be done. Okay, which one is greater? If 8 is greater than 5, then a swap will be performed. Okay, in that swap the value means the place of 8 will be replaced with the place of 5, so they will be interchanged. Then again the comparison between 8 and 7 will be done. Then again 8 is greater than 7, again one swap will be performed. Then a swap between 8 and 3 will be performed. Again 8 will be greater, so it will be swapped, so on. 8 will come to the last. Okay, and when all the comparisons are done, at the end we will get 8 at the last place, at the place of 2. Okay, and the rest of the elements will be as it is, means how the swap was performed, it will be like that only. So this whole comparison to make to find the largest element, to find the first largest element, will be called as pass. Okay, so on, multiple passes will be performed to sort this array, and at the end we will get, suppose if the size is 5, so at the end there will be four elements. We will find four largest element, and the last element will be automatically in sorted order because we have find the four largest elements. So the first element will be the smaller one only, so we will perform till 4 only if n is equal to 5. Okay, now the same thing is written here also. Okay, so now I hope you have understood pass. Okay, what is pass? So now in each pass pushes the largest unsorted elements to its correct position by repeatedly swapping adjacent elements if they are in wrong order. Okay, now let's just understand this line by one example. Okay, let's suppose we are in the first pass. Okay, and this is our array as it is, as you can see here, 85732, 85732. Now the comparison will start between 8 and 5, the adjacent elements, means the elements which are just in there, means side by side. So 8 and 5 are the first two elements, so the comparison will be done between these two. Now 8 is greater than 5, so a swap will be made between 8 and 5. So the next value which we will get is 58732. Now the comparison will be done between 8 and 7. Now again 8 is greater than 7, one swap will be performed. Now the next value will be 57832. Now the swap will be done between 8 and 3. Again 8 is greater, swap will be made. Okay, now the next value will be 57382. Now the comparison will be done between 8 and 2. Again 8 is greater, so swap will be made. Okay, now at the end we will get the first largest element. So the array, the list will be 57328. Okay, so we have found the last element which is the greatest element for now. Okay, so 8 is the greatest element. Now how many comparisons we have performed here? Okay, let's count. One comparison, two, three comparison, four. Total four comparison. Okay, how many swaps we have made here? One, two, three, and four. Total four swaps. So actually, swaps are considered as maximum swaps, okay? Because there will be some times where swap will be not performed. So we are going to perform take in consideration the maximum number of swaps that can be performed in the following swap or in the following pass, okay? So yeah, and the actual swap is also 4 here. Now, so this is at the end of the first swap, first pass, we have this list 57328. Now, this list will be continued in the second pass because we have find the last element in the first pass. So now we are going to find in the second pass the second largest element. Okay. Now let's move on to the second pass. Okay. 57328. Let's take consideration this 5 and 7. So 5 is not greater than 7. So no swap will be performed. Okay. Again, the same list will be taken in consideration further. 5, 7, 3 to 8. Now the comparison will be done between 7 and 3. Now because 5 was not greater than 7, so 5 will be leave as it is. Okay. So now 7 and 3 will be compared. 7 is obviously greater than 3. A swap will be made. Now, next time 5, 3, 7, 2, 8. Again, in 7 and 2, 7 is greater, a swap will be made. Okay. So at the end of this pass, we will get 5, 3, 2, 7, and 8. Okay. So last two elements we have get. Okay. So last two elements are sorted, and this 7 is the, okay, 8 and 7 are what? The last greatest elements. Okay. Now let's count how many comparisons we have made. So we have made one comparison, two comparison, and three. So total comparison done here is three. Maximum number of swap, okay, that can be performed here is one swap, two swap, three swap, okay. But how many swaps actually we have performed? So only two swaps actually we have done here, because in the first case, as you can see, 5 was not greater than 7, so no swap was done, okay. But what I have told you that we will consider the maximum number of swaps that we can do. So maximum number of swap was 3, so we'll consider that only, okay. Yeah. Now at the end of the second pass, this is the list which we are getting 5, 3, 2, 7, 8. This list will be followed in the third pass. Okay. Okay. Now 5, 3, 2, 7, 8. Now first two elements will be compared 5 and 3. So 5 is greater than 3. A swap will be made. Okay. Now next time 3, 5, 2, 7, 8. So 5 and 2 will be compared. The next adjacent elements. So 5 is greater than 2. So swap will be made. So at the end of the third pass, this is the list 3, 2, 5, 7, 8, which we are getting. And we will see now at the end of the third pass, we have get the last three elements which are sorted 5, 7, and 8, which are sorted. Okay. So how many comparisons we have done in the third pass? Two comparisons. Maximum swap, what was the maximum swap? Only, you can see here only two swaps, and actual swap was also two. Okay. Now let's go to the last pass, fourth. Okay. Here we'll take this list as consideration 3 2 5 7 8 3 2 5 7 8. Okay, now comparison will be made in 3 and 2, the first adjacent as elements. So 3 is greater than 2, so a swap will be made, and 2 3 5 7 8, this is our sorted array. How many comparisons? One. How many maximum number of swaps? One. And actual swap is also one. Okay, now what was the total number of passes here in this following array, or you can call it as list? So total number of passes were 4. Okay. Why 4? Because the total number of elements were 5. So total number of passes were 4. So we can write it as n minus 1. So that's why I have considered 5, n equals to 5 here. Okay. So this 5 is the size of the elements present inside our list. Okay. Or you can call it as a data set. So if there are n number of elements, so what will be the number of passes? N minus 1. Okay. So that I have written here, that n minus 1. Okay. Actual passes done 4. Maximum possible passes are also, in the case of 5, it is 4. In the case of n, it is n minus 1. Now let's calculate the total comparison. Okay. And in the criteria analysis also, I have told you that total comparison is that the total comparison is it decides the time complexity of the sorting technique. Okay, so the time complexity is decided by the total comparison only. So yeah, so let's consider the total comparison for five elements. Okay, so for five elements, how number of total number of comparisons? Okay, so four. So in each case, one, two, three, and four. As you can see in the fourth pass, there was only one comparison done. In the third pass, two comparison done. In the second pass, three, and in the first pass, there was four. So that I have taken because you can see they are in natural numbers. So one, two, three, four. So one plus two plus three plus four. Okay. So from that we are deriving this that the degree of the time complexity will be n square. Okay. Now how we get this n square? Let's discuss that. Okay. Now, in bubble sort, on each pass, we compare adjacent elements that we already know, that we have already seen, which pushes the largest unsorted elements to the end, and comparison decreases by one in each case. Yeah, this line. As in the in each pass we have seen, in the first pass there was four comparison, in the second there were three, then in the third there were two, and at last pass there was only one. So we have to go to one. So comparison decreases by one in each pass, and we have to reach till one comparison. Okay, so that will be considered as last pass. The pass in which we have reached the one comparison state, that will be called as the last pass. So for n elements in the first pass, there will be n minus 1 comparisons. So suppose in the first pass, if there are 5 elements, so n minus 1, 4 comparisons we have done. In the second, n minus 2. In the third, n minus 3. And at the last, we have to go until one comparisons. Okay. So this will form this arithmetic series, okay, which is similar to the sum of natural numbers formula, n minus 1 plus n minus 2 plus n minus 3, and so on. It will be move forward. So as you can see, it's the same thing we can consider at this sum equals to k, okay, k plus 1 divided by 2. So in our case, if we'll replace k with n minus 1, so we'll get this polynomial n minus 1 into n divided 2. So if we'll calculate this, we'll get n square uh, minus n by 2. So what is the highest degree? We'll consider the highest degree of the uh, highest degree. So what is that? It is n square. We'll get n square. So that's why n square has been taken into consideration. So the time complexity will be n square. Now for the maximum swap also, you will see the maximum swap also is be taken similar as the total comparisons. So it will be also as from that also you will get n square only. Okay. So this was how bubble sort works. Okay, step by step visualization how it is works in each pass. Now I hope you have understood everything. Okay, now let's do what, uh let's go to the programming. Let's write the code. So include iostream using namespace std. Let's create the main function first. So in the main function, uh let's take n1 and n2, or let's just take user input. Okay, so int n and cin. Before that, I'll give you a cout that enter the elements. Let's start a for loop to read it. So int I equals to 0, and here we'll take n, Okay, I less than n. What we have to do, we have to see in ARR, okay, ARR of I. Okay, so now we have read the array. Uh, then we'll create a function for a bubble in which we'll take ARR and n. Okay, so this is going to, and then we'll print our array. So I'll just change it to cout. Okay, or everything seems okay. Operator needs to be changed to this. Okay, yeah. Now let's create the function for doing the bubble sort. So void bubble, it will take a array as a parameter and the size of the array as a parameter. Okay, now let's start a loop. Okay, so for int I equal to 0, now you only tell me that the loop will go, it will start from 0, but where it will go till? It will go till, if it is 5, suppose if the number of elements present in the array is 5, so it will go till n minus 1. Okay, that we have already seen. Okay, that's good, n minus 1. And then again we'll start one more loop. Okay, j, and here n, so it will also be n minus 1. Okay, because we have to do comparison between the adjacent elements, so that's why we need a nested loop. Okay, okay, nested loop. Now in j equal to 0, j less than n minus 1. But one more thing, in the passes we have already seen that each time n minus 1, then n minus 2, then n minus 3, and then n minus 4 was there. So that thing how we can achieve? So value of I is also getting increased one by one. So what we can do here, n minus I minus 1. So each time the value of j will also be decreased. Okay, so that we are taking in consideration. So that is the main logic thing in bubble sort. Okay, now everything is easy. We have to just compare between uh, the adjacent side elements. So if a of j is greater than a of the next element, okay, so a of j plus 1, if it is greater than that, then we have to make a swap. So I'll have to create a swap function. So a swap will be done between a of j and a of j plus 1. Okay, now I have to create the swap function. So for that I'll need to create a swap function. So I'll create it void swap. Okay, this is also going to take an array. Okay, no, and this will give x and int y, and a simple swap will be made. So in temp, I take a temp variable in which I'll swap give the value of pointer x, and in pointer x I'll provide the value of pointer y, and in pointer y I'll provide temp. Okay, so the swap will be made automatically, and now I think we are ready to go, and it will work as it is. So let's do what? Let's execute the program. So let's write the name bubble.cpp /a. Enter the number of elements 5. Enter the elements 5, 4, 3, 2, and 1. So now you'll see your array has been sorted. Okay, 1, 2, 3, 4, 5. Okay, so this is the code for bubble sort, and so easy it is. You have to just start a loop I equals to 0 and go till n minus 1. That we know why we have to go till n minus 1. Now then we have to compare between the adjacent elements. So we have to we inside the array we have to work. So for that we need one more array. So that's why we have taken an array, one more loop, not array. We have to take one more loop, nested loop. Okay, and that will take j, and j will go till n minus I minus 1. Okay, why? That we already know. And then we have to make the comparison using the conditional statement that a of j, if it is greater than a of j plus 1, then make a swap. Okay, Now, number of comparisons that we have already seen, number of swaps that we have already calculated. Now, let's just do what? Let's just see that how it is adaptive and how it is stable. Okay. So for seeing adaptive, that how it is adaptive, we have to add some more lines of code in this. Okay. So what we'll do, we'll add a bool swapped, and initially we'll make it false. Okay. And whenever, if the swap is made, so it will become true. So when a swap will be made, it will become true. Okay. Then coming out of this loop, what we are going to do, we'll again start a loop in k, and we will print the number of k equals to 0, k less than n. Okay. Now, here we'll print the array. So C out a of k. Let's give a space. And after that, let's put a C out endl. Okay. And if not swapped, okay, if not swapped, so then C out array is already sorted, exiting early, after I plus 1 passes. Okay. Endl. Okay. So this condition will be taken in consideration when swap will be, when in the first pass only. Okay, there will be no swap made. Okay, in the first pass only. So it will be not swapped, means it will not be true, it will be false only. So for false condition, we are checking it when swap is not equal to true, and then it will be printed. Okay, now let's give one more thing, C out and pass I plus 1, so that total pass should also get printed. Yeah, endl. Okay, now I hope this code will work. Okay, so that I can show you that it is adaptive in nature. So yeah, okay, let's run the code again. Number of elements 5, and enter the elements 1, 2, 3, 4. So in pass 1, it is array is already sorted, existing early after 1 passes. Okay, that's good. Okay, why it is printing so many times? Okay, we forgot to put the break here. Okay, yeah, now it will work. Okay, so pass 1. After pass 1 only, means after first check, array, it find out that array is already sorted. So it just exited after first pass only. Okay, so this shows that it's just for this case, if the array is already sorted, the bubble sort will do what? It will, the degree will be n only. Okay, so it will take the best time, that will be as n, if the array is already sorted. If it is not, so then it will take, okay, as many it will be needed, so it will be take n square times. So yeah, so that satisfies that it is adaptive. Okay, but because it is taking a minimum time. One more thing, stable. How we can say that stable? What do you mean by stable? That we have already seen in the criteria analysis. Stable means that if it is maintaining the previous value, okay, previous content, previous positions of the, if we are finding some duplicate elements, so if it is following the same path, means suppose uh, let's take in consideration a data set like this, 5 4 5 3 2 1. Okay, so this is suppose the data set. So which one will be, which five will come first? Obviously the first five that will be there, okay, and the last. So same thing that will be, is not going to change. Why? Because in the condition of the bubble sort, if you have, when we are making the comparisons, we are not making it with equal, that is there is only greater than. If a of j is only greater than a of j plus 1, then only it will be swapped. If it is equal, then there is no swap. So the position will be maintained. So because of that, it is stable also. Okay. So this is how all the analysis we have performed on bubble sort. We have seen the working of bubble sort also, step by step visualization of bubble sort, and the code implementation of bubble sort. I hope you have understood bubble sort now. And at the end, I'll show you one more thing about bubble sort. Okay, suppose this rock, suppose this whole thing as a water, and this rock, as you can see, it is the largest element. So when this rock falls on the water, it forms some bubble, because rock has to make its space. So all the air, okay, in the form of bubbles, they just go. So these bubbles are the smallest elements, as you can see, which we are making their spaces. So the lighter elements will go upwards and the heavier elements will come in the bottom. Same thing, the same concept has taken in bubble sort. Whatever the largest elements are, they will go in their side, okay, and the lighter elements, they will come in other side. In this way, the whole list or data set will become sorted. Okay, so I hope you have understood bubble sort. Thanks for watching the video. Stay tuned up. We'll see you in the next video.